Hello and welcome to the Wednesday, September 24th, 2025 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich, recording today from Las Vegas, Nevada. And this episode is brought to you by the SANS.edu Graduate Certificate Program in Penetration Testing and Ethical Hacking. And today's Internet Storm Center diary comes from one of our undergraduate interns, Tyler House. These interns are looking, at honeypot data. And in this particular case, Tyler looked at what kind of looks like a denial of service attack. It certainly had a reasonably high volume, about 2.3 million packets from about 6,000 different hosts. But, if it would have been a honeypot and it would have been a reasonably sized web server, it probably wouldn't be enough to actually cause a denial of service attack. So one of the things that Tyler was investigating is, maybe the denial of service attack was more kind of a smokescreen to hide any other attacks that may have been going on at the same time. This is certainly not an unknown technique and has been done in large and smaller attacks alike to essentially distract the analyst and also distract resources that are then typically more focused on the more visible, the more obvious denial of service attack that, of course, also has the more immediate impact, at least initially, in order to then distract these resources and have the actual attack slip underneath that particular smokescreen. Well, in this case, it wasn't quite that clear. There were some other scans for Git configuration files and the like that happened around the same time the denial of service attack happened. It's possible that that was the attack they tried to cover up, but then again, it wasn't really sort of an attack that was really worthwhile covering up with any significant amount of resources. We also have sometimes seen these type of small denial of service attacks being either launched just by accident, where essentially an IP address was mistaken, or maybe a host name did still point to an unrelated IP address. Unclear exactly what happens here, but real nice analysis into the type of attack that happened here, what identified the denial of service part of the attack, and then, of course, also the underlying smaller attacks that try to access specific URLs. And GitHub published a blog post stating some of the lessons learned and actions they'll take in order to prevent a repeat of the recent NPM package hijack. Remember, the root cause here was a successful phishing attack that compromised some popular packages, and then in the next wave, they also used these popular packages that they had hijacked in order to infect additional packages. There are really three actions that GitHub will take and also recommends maintainers will take in order to prevent something like this from happening. The first thing is the requirement for two-factor authentication, where they particularly emphasize FIDO2 instead of just time-based one-time passwords, which is sort of your default, usually two-factor authentication scheme. FIDO2 is inherently phishing safe, so that's why they're pushing this form of multi-factor authentication. The next thing is that they're going to switch to more granular tokens, or are forcing developers of these packages to use more granular tokens as part of your build pipeline, which is often not interactive, so there's no user that can actually take part in an authentication process. You're using these API tokens, and historically, GitHub has often used these API tokens that basically have access to everything, while with more granular tokens, the damage would be more limited if the token is leaked. But even these tokens, of course, could get leaked and could cause a compromise of the packages. So the third item that GitHub is proposing here is what they're calling trusted publishing. Trusted publishing moves away from tokens based off API tokens, which are really just secrets to OAuth based OpenID Connect system where you are using JWT, so JSON Web Tokens, which are digitally signed and time limited for authentication of these automated processes. We'll see how it all works out. The steps make a lot of sense inside of the recent attack, and I hope developers will also find them not too difficult to implement. And SolarWinds released yet another patch for its Web Help Desk product. This fixes, well, actually still the same vulnerability in the AjaxProxy. It's a deserialization vulnerability. This is the third patch for this particular set of vulnerabilities. They have individual CVE numbers, but it's really all the same vulnerability and then various patch bypasses that still allowed exploitation of the deserialization vulnerability. Haven't looked at the patch yet, not sure if it's sort of publicly available, but a typical problem with deserialization vulnerabilities is that one way to patch them is to remove the gadgets, basically the classes, the objects that are being used to exploit the particular vulnerability. And that basically comes down to a block list. If the block list is incomplete, then of course the underlying vulnerability is still exploitable. And we have seen similar issues with other products where we had sort of these incremental patches where additional objects, additional gadgets were being added to the block list. And Supermicro patched its BMC firmware, patching two vulnerabilities that would allow a malicious actor to essentially upload rogue firmware. The vulnerability is a cryptographic signature validation issue, where essentially the validation logic that's supposed to allow only authenticated firmware to be uploaded is being bypassed, which then essentially could lead to a compromise of the BMC. Well, and that's it for today. So thanks again for listening. Thanks for liking and subscribing. And as always, thanks for recommending this podcast. That's it for today, and talk to you again tomorrow. Bye.